Hi guys, it's Mr. T here, and I'm at my virtual location, my virtual beach, as it were, and I'm here to see what I can do to give you a little help with topic 1, section 2, Math Excel practice problems that were assigned. So let's jump into this thing, okay? All right. So here we go. So question number 1, here we go. It says without graphing. Identify the vertex and axis symmetry of the transformation, okay, from the parent function of the absolute value of x, okay? So let's get my writing utensil here. So what would that look like, okay? So just a quick sketch here. What's the absolute value of x look like? Well, it just starts at the origin and goes up, the slope of 1 and -1, right? Okay, so how has this moved with this guy? Well, what's our formula? Remember, it's going to be y equals a absolute value of x minus h plus k. So we need to, and we notice that the h and the k will be the vertex, okay? Will be the vertex. Now, it would appear that k is equal to 3, right? It's in the 3 spot. And it would also appear that 1 is h. But if you'll notice, it says x plus 1, and this says x minus h. So in order for that to work, that's actually going to have to end up being rewritten as x minus -1 plus 3. Okay? And there's nothing written in front, so what are we going to assume is in front? A 1. So now that we've rewritten it, so we can clarify some things, because this is how we need to write it, the format. Okay, so in front, we've noticed that the A is equal to 1 now. Okay, so that will be asked here in a minute. We'll need to look at that. And so the H value is going to actually be -1. There's your H. So that's why we didn't need to graph it, because we can see that now. But what I'm going to do is I'm going to pull up this calculator right here, and I'm going to put my little face down here. I'm going to go ahead and put this in here. Now, where are my absolute value bars? Well, let's hit alpha y equals. How about, which is F1, how about window? Oh, there it says ABS. Okay, that's absolute value. And then there's going to use the X button, and then +1, arrow out, and then +3. And now when I hit zoom 6, you notice what happened to it. It did go left 1, not right 1. So that's why I always say outside's up and down, inside's left and right, but opposite what it appears. So this one went up 3, okay, went up 3 and left 1, or left 1 and up 3, whichever one you can say. So it seems backwards of that +1, but it isn't really, okay? And then it has, and it didn't change shape. It just still has that 1-1 slope. Okay, so I just wanted to kind of make that connection, since this was the very first one we did, even though I said didn't have to graph it, but that wasn't the point. All right, so let me put this here. Let's put in the vertex. So I'm going to use this little tool down here. That's helpful. I could type the whole thing. That's good that they helped me out there. So we got -1, and then arrow over to the next box, and that's a 3. Okay. Why they had to delete that off? Okay. So get this guy back over here and check his answer. It says, well done. Awesome. I feel much better about myself already. Now, the axis of symmetry. What is that? Well, just as a refresher, the axis of symmetry would be the line. Okay, we can usually draw it and dot it that goes right through the vertex of an absolute value or a parabola. And a vertical line is, whenever you have a horizontal vertical line, it's either going to be like x equals some kind of number, or y equals a number, right? So let's see here. Does this line go through an x value or a y value? What has a whole bunch of y values, right? But it only goes through the x and y. So it's going to be x equals 0, where y equals 0 would be horizontal. X equals, it's going to go vertical because it touches the x in one spot at 0. So this is going to be y equals 0 for the axis of symmetry, okay? So axis of symmetry. All right, so let's go put that in. We said that so it's always the x value of the vertex. So it's always x equals h. So this is hk, and this is x equals h for the axis of symmetry. All right, now let's check that answer. Boop. Excellent job. Now, we said this is going to go. Which one of these says left 1 and up 3? Because it did not get stretched, right? So anything that says stretched by a factor of 3 is automatically out. Up and down 1, that's backwards. That's up 3. Okay, that's 1. All right, so I think it might be this one. Now, yours might be in a different order. You might have different numbers for that matter, because a lot of these, but it's the same idea. Okay, so it's going to be what, 1 unit to the left, 3 up. So for me, it's E. Okay, there we go. And 1 down, ready for our next one. Okay, so let me go ahead and label this guy. Number 2. All right, so let's read it. Write the function rule for the function shown below reflected across the given axis. They like to make this stuff look fancy, don't they? Reflected across the x-axis. So the x-axis is this one. And if you got something like this and you reflect it over, what would we call that? We call that being flipped over, don't it? It's a flip. It's a vertical flip. So how did we flip lines? To go from positive slope to negative slope, we just stuck a negative in front, right? So let's do the same thing here. Let's just stick a negative in front, and I bet you that's going to work just fine. Okay, so we're just going to write negative 3x. Now, if it was the y-axis, well, that'd be a little different story. But for the x-axis, it's just a vertical thing over the x-axis. So I got to kill that right there and type it in. Negative 3x. And then come down here and say check answer. Fantastic. I mean, we're cruising through now. All right. This is number 3. So let's label this guy number 3. Okay. I'm going to try to do this so that when you're scanning through for help, you can see that much easier. Now it says, this one says, make a table of values for the following equation, then graph the equation. So what they're wanting to do is we're going to plug in negative 3 up here and then negative 1, get those ordered pairs, and then plot those points, or at least a couple of those points, to get our graph. So what do we got? So if we got negative 3 right here, so that's going to be what? Absolute value of negative 3. So that's going to be what? 3 plus 2, which is 5. So we're going to put a 5 right there. Okay. Now, how about a negative 1? So that'd be absolute value of negative 1 plus 2. That's terrible looking. So that equals 1 plus 2, which is 3. So there's your 3. Okay. 0 plus 2, of course, is going to be 2. And then 1 plus 2 is 3. And 3 plus 2 is 5. Ooh, that's flaky there. Let's go 5. So Oh, that's interesting. You see how that worked out? So 0, 2, I bet, is the vertex. And then we got those 2 points and then these 2 points. How about that? So real quickly here, I'm going to jot down the vertex on my little piece of paper because when this information goes away from me. And so that when I hit this button here, I can transfer all that information easy enough. 5, 3, 2, 3, 5. All right, so let's go on down here. Good news. And now they want us to pick the graph. Okay, so notice it's positive in front, so that means it's going to open upwards. And it hasn't moved left or right at all. It's only moved up 2 from the original thing. So that one's wrong because it's opening down. That one's opening up, but it looks like, let's look at that. Yeah, the original would have started at the origin, so that one moved down 2 instead of up 2. Okay, this one's upside down. This one looks like it, look at the vertex, it moved up, so there we go. So there we are. And so let's get this closer, check our answer, and voila. Doing good, doing good. Now, and remember, for you, you have these features that, and I might end up using before we're done. Help me solve this, see an example, get more help. Get more help usually is mostly just a little short video that's real. Unfortunately, it's more generic. This video is more specific, but it is got some generic and it's got some graphing tools and some things like that. Most people are big into the view example, but be careful about how much you use that. It's a good tool, but like I always say, the person who does the work does the learning. So if you don't try first and get your brain to working with this, it doesn't have as good effect on helping you learn. Okay. All right. Let's try our next one here. Number 4. Just make a table of values of the following equation, then graph the equation. So basically what we just got finished doing, but they're showing you the steps here. Okay. They're showing you how it put together. So where we were doing it ourselves a while ago, we just got to figure out what these numbers are. So -1 and +1. Let's get a little bigger here. And this is number 4, right? This is number 4. I guess I'll go ahead and do that. Number 4. Okay. And so that's 0, and the absolute value of 0 would be 0. That's 1, 2, 4. Okay. So again, I got to do a little jot here. Interesting enough, let me double check myself, make sure I didn't mess anything up. All right, that's -3 and 2. Oh, it skipped the 2. I was like, the pattern seems weird to me here because I'm not really sure where the vertex is from what I'm seeing here. Okay, but we'll take it. We'll figure it out because we got this 0, 1, 2, and 4. Okay, I definitely see this -3, 2, and 1, 2. So one of these guys has got to be the vertex. Let's say since the -2 is the one missing, that the 1 is going to be our vertex. -1, 0. But I'm getting ahead of myself. Okay, it likes that. Now it wants us to pick it. Okay. Oh, they just gave it. So this is x plus 1. So we didn't have to graph it. We just got to match the graph. So when we're looking at x plus 1, that's on the inside. And it looks like it moves right 1, but no. On the inside, it's backwards. So that's left 1. So which one of these was moved left 1 unit? Well, this one's right 1 unit. Again, yours will be in different orders or stuff. Oh, this one's mine, B. Let's look at the other two and see what they did. Okay, this one's right 1 unit, but opening down, which would need a negative in front. This one is left, but it's again opening down, so that would be incorrect. So let's give it a big check, and voila, here we go. Okay. All right. Oh, this one's just straight up, just straight up. We have to do the ordered pairs. So let's look at this. So we've already talked about what these parent function looks like, just that v, and it turns out that my b is the parent function, so that's definitely not it. Okay, if you put a 2 on something, is that going to make it steeper or less steep? Well, let's think about that. That's like 2 over 1. So up 2 over 1, up 2 over 1. That's making it steeper, right? Making it steeper. So we would take what's the parent function, which is this guy right here. It needs to be more narrow. But what else is it going to do? It's going to flip it over. So A here did flip it over, but it's wider, not more narrow. So it's like, so oh, there it is. It got flipped and it's more narrow. And I can probably get this where you can see the pattern to it. Okay. Well, come on. Come on. You can see this 1, 2. I mean, so rise 2, run 1, rise 2, run 1. So that's a slope. So 2 over 1 on that side, and then it's negative going on the other side, like absolute values do. Okay, so there's your rise 2, run 1 slope. So that is definitely what we're needing there. Okay, and then that one's still not facing the right way, and it's opening too far. So that's part 1. What are they going to want us to do next? Excellent. Very good. Describe it using words. Okay, so from the parent function, it was reflected over the x-axis and also stretched by a factor of 2. Stretched. We talked about that in the lesson. So we see the reflected, no, not over the x, or the y, it's over the x. And then, but it was, that doesn't have, it was vertical compressed and reflected over the x. Okay, very good. A vertical compression. Oh, no. No, I got that. I was about to mess that up, didn't I? A vertical compression would do what? Make it wider. A vertical stretch is going to do what? Make it more narrow. And then it was also what? Flipped over. So that's going to be a D for me. It's vertical stretched and reflected over the x-axis. Well, if I had made that error, it would have told me. And then I would have looked at it more closely and said, whoops, didn't read close enough. Got to be careful. Fantastic. So that was number 5. All right. Forgot to label that one. Oh, well. Okay. Well, now this one's going to be interesting. And this is number 6. This is number 6. Okay. That's an interesting picture right there. I'm sure some of y'all think, oh, that's kind of weird and scary. Well, let's just take it one step at a time and see how this rolls. Okay. All right. The graph the function f of x, and then we're going to make a table for f of x and x plus 5. Well, that seems confusing. Well, let's not get ahead of ourselves. This just says x and f of x. So that means we're going to take where x equals 2 and look where y is equal. So up here, okay, so up here, where does x equal 2? Right there. And the y value is 0. Got it. Okay, now 3. Over 3, come up here, and that's 3, 4, isn't it? So 3, 4. And over here to 5, and we come up here, and what is that? So it said the nearest half unit down here, nearest half unit. So this is 4, that's 5, so it looks like that's 5.5. So we're going to go 5.5. Best, I like improper fractions. They aren't really convenient for graphing. And then 7, 0. So we just had to look at the picture for that one, okay? All right, 7, 0. So I'm going to make a note of these, okay? So 2, 0, 3, 4, 5, 5.5, and 7, 0. Okay, so that wasn't too bad. Let me do this, and let's actually put the numbers in. 0, 4, 5.5, and then 0. Okay, well, there we go. Good. So let's go to part 2. This is going to be a little bit more interesting. Okay. So what does this mean? So a while ago, we plugged in a 2 for this spot right here. Well, now we're going to plug a -3 into this spot. So what does that look like? All right, let's go grab my wheelie here. All right, so it didn't cut me off too bad. So we're going to say it's going to be f of x. So I'm going to put a blank where the x is and put a +5 here and close. So we're going to plug a -3 in right here. Doop, doop. Oh, that's an ugly 3. Okay. All right. And so again, we're doing 6. And -3 plus 5 is going to give me f of 2. Well, what does f of 2 equal? That's 0. Okay. And then we're going to do this. So that means there's going to be a 0 right there. All right. So 2 shifted to the left or right? 2 ended up being shifted to the left, even though it says +5. Again, you notice that +5 is on the inside of the parentheses, and when it's on the inside, it seems to go backwards. It gets a little crazy and goes backwards. So it's a little stir crazy on the inside. All right, so let's try another one here. F of, put my little box, +5. Okay, I'm going to take my 2, my -2, put it in the box. That's what we did before, just plugged it in here. So -2 plus 5. So it gives me f of 3. What does f of 3 equal? Well, that's the f of right here. F of 3 is a 4. Okay. Now, if I had a full equation, because this is a parabola or regular, we wouldn't, go back to the table. We would just use the equation. But that's the whole point of the exercise, is they're trying to get you to use the table and make the connections there. That's why they're using this little weird shape. Okay. After we get through this first topic, we don't really use these weird shapes anymore, but they're trying to get you used to the notation and not just working it through the other stuff. So that's kind of the reason for it, but it's kind of weird, I know. All right, so 0. Well, what's 0 plus 5? Well, that's 5. Well, what's 5? Okay, that's, you notice that, hey, these guys just end up meaning the same thing. And then 2 plus 5 is 7, so that's 0. So what happened here? Did the y values change? No, it's a left and right shift, not up and down. It's a left and right shift. So I'm going to graph these points real quick. So -3, that's over here somewhere, right? -3, 0. -2, 4, right about there. 0, 5.5, and then 2, 0. Well, what just happened? It shifted left, didn't it? So the +5 is on the inside, so that's left and right for certain. Okay, but it's instead of going right 5, it went left 5. So inside's always backwards of what it seems, but the formula actually handles that for us. Okay, so I'll quit jabbering here and get to it. I think I've made my point. So we're gonna get to plugging in some numbers. Okay, you'd like that. And I think the next thing is going to ask us to match the graph, and we've already done so. So these up and downs are automatically out, and we notice that it went to the left. So this guy here is what we need. Okay. Okay, we're all good. And so we're going to move on to 7. 6 is a very interesting little character there. So let's move on to 7 here. Let me Grab my paper here. Okay. Okay, so describe the transformation that produced g of x. Oh my goodness gracious. Okay. So let me grab here. So this is number 7. So what happened from f of x to g of x? Well, one thing I'm noticing here is what's the same? They both have a 6x, don't they? So what are the new things? The new things are the 7 over here and the 7 over here. Okay. So 7 on the outside makes it go up and down, right? Makes it go up and down. So I need, and that's an up. So I need something that goes up 7 units. That's good. Something else that makes it go up. That says up 7 units. Oops, that's up 1/7 unit. That is not right. Fact, that's about stability. Up 1/7. So that's bad again. So it has to be one of these two guys that say up 7 units. Okay. So if I take something and times 1/7, is that going to be a vertical compression or a by a factor of 1/7? But first, there's a vertical compression of a factor of 1/7. First, there's a vertical translation of up 7 units. There's a vertical compression by a factor of 1/7. This is a vertical compression by a factor of 1/7, and then a vertical translation up 7 units. Well, that's very interesting. They'll say the exact same things in a different order. Well, since the 1/7 comes first, we're going to go with this one. Let's see what happens because it's really the same thing, but let's see what happens. I'm always good for a nice experiment here. Okay. So let's go here. Boop. Well done. Should have checked the other one. Should have checked the other one because it's exactly the same. I think it's probably more of a typo, but okay. So we did it from left to right, and that's how that went there. So that's a little tricky question because they're exactly the same thing. What we could do to always we could grab our calculator here and confirm that information. Okay, you can always confirm that information by let's put clear here. We got 6x. Let's see, there's that graph there, and then we come up to y equals down here. So we got 6 over 7x plus 7. And see, and lines are a lot harder to see, but it did go up 7. And then if you were to take and push down on that, it would flatten out some. Okay, so that's interesting. All right, so you also notice that while we don't do a whole lot of this in Algebra 1 with lines, because it's a little harder to figure out what's going on. Just, and there's really no point. Okay, here we're on number 8. We're on number 8 here, and I'm going to be honest with you. I spent several minutes working with this and found some quirks. And there's two things that went wrong with these quirks. One is I did not read the instructions carefully, and then there's another thing that it didn't actually say. It assumed I was supposed to know, but I will point those out as we go through. All right. So here we are, number 8. It's going to ask us to sketch the graph of the equation and the axis of symmetry. And then we're going to do that both on the graph. That's the part I forgot. Number 1, I forgot to sketch both of them, so I couldn't figure out what was wrong. And then number 2, when you sketch the axis of symmetries are always done with dotted lines. So you got to change that. So I'll show you that. And then afterwards, we're going to state the vertex and the axis of symmetry. So first of all, we know that this is a parabola and it's going to shift up 4 and left 3, right? Because the inside's opposite what it seems. So let's go in here. Look at this right there. And so for a parent function, and I just not trust me, okay, I'm just going to show you what the parent function would be. Parent function starts here, and then if I plug in a 1, 1 squared would be what? 1. What's 2 squared? 4. 3 squared is 9. 4 squared is 16. So that's what the parent function looks like. And so as long as we're not stretching or compressing, we can just use the vertex and over 1 and up 1 and we're good. Now, if it's stretched or compressed, we're going to have to, it'd be a little different. So let me clear this guy because what's it say? Yeah, I want it cleared. Ooh, okay, let's double check ourselves. We're going to go left 3, up 4 from the origin. So left 3, up 4, and, well, I got to type this guy first, okay? And then I click here, and there is the vertex. Now, and then over 1 and up 1, and there is the parabola. And if I save it now, I will have the correct parabola, but I did not follow the instructions. They also want the axis of symmetry. So first time I tried it, I forgot. So I'm sure you've run into the same frustration possibly, and that's one of the reasons why you're watching this one. So, and then I said the axis of symmetry goes straight here, but then I forgot, well, the axis of symmetry is usually a dotted line. So that's that feature there on the tool is a dotted line. So I'm going to hit here and then go straight up, and there is going to be our axis of symmetry. So that's always the x value of the h and k. All right, so there we go. We got that saved. We hit check answer, and it's much, much easier this way. So one, I got to read the instructions, and two, it's one of the things we got to remember that we're supposed to know. Axis of symmetry is a dotted line. Okay, now it should be much, much easier. So we're going to say that vertex there is -3, 4. So I click inside here. Go ahead and grab that. -3. And I can hit the arrow here, but you notice it's not inside the box. So I do it one more time, and now it's going to say inside the box. It's kind of weird. Or you can just click inside the box. Enter. Yep, it says excellent. And now for the equations for the axis of symmetry. So that's always going to be an x equals the x of the vertex. So that's just x equals -3. And voila. Here we go. So x, finally done. Okay. You're getting the short version, not because I cut out all the what? What? Yeah, which I'm sure you remember doing that yourself. Maybe you didn't. I hope you didn't. I did not read carefully. So here we go. This is number 9. Number 9. So let's kick this in here. Let's write 9 up here. So when people are scanning, not there or there. Let's put it over here. 9. Sketch the graph of the quadratic function. Okay. And so this one's what? I'm going to go left 3 and down 6 using the translations. That's what's compare it to the parent function of x squared. Graph that exactly the same. The graph of that is exactly the same as the graph of this, except for it shifted 3 units left and 6 units down. Okay. So 3 units left and 6 units down. And you can always put those both into a calculator and look at them. If you're not comfortable with that just yet, check answer. And that's part 1. All good. And now that we don't have to do the sketch, we just got to go see which one of these was moved 3 units left and 6 units down. Well, that's up. That one's up. That's right. That's left. See, left. Get that straight. Okay. Whoop. Number 9. Excellent. Moving on. Okay. Here we are for number 10. Oh, this one's going to be a little more interesting. It's going to be a little more interesting. So let me get this going here. Label this guy number 10. All right. This one's going to be a little bit more to it. So what we're going to do is we're going to use this vertex formula in this graph, and they're wanting us to write the function for it. Okay. So a while ago, we were using the function to figure out the graph. Now they're wanting us to do it in reverse, which is how we do a lot of things in math. We do add, subtract, multiply, then divide. Now they gave us the equation. They want us to do the graph, and now they give us the graph, and now they want the equation or the function. Or another word we're going to get used to, the model, the rule. So all of those are kind of synonymous words. So equation, the function, or the function rule, or the model, all mean basically the equation for the graph. Okay, so what we're going to do here is I'm going to rewrite this entire thing with a bunch of boxes. Okay. Okay. So there's where the y goes, or f of x. Here's the a. And what we're going to do is we're going to come over here and see how many of these boxes we can fill in. Okay. And then how many we just got to put a variable right back in there because we don't know yet. Now, what we're going to hope happens is every box is going to get filled in except for one box. And then we can use our amazing algebra skills to figure out what that one variable is. Because when there's more than one variable, we can't really use our equation solving skills. We can graph, but we can't really solve an equation. So let's see what's going on here. So we have -2 and 8. You got to be careful. I tried one a while ago and I missed the negative, and I should have noticed it, but messed it up. So you got to watch out for that. So here we go. So this is going to be the H and the K because that's the vertex. So -2 goes here. Notice I said that's the minus -2, and then the K is 8. So that goes there. Okay. This is the A, or the slope. And now if it was a line, we could just kind of calculate here and figure out the slope. But with parabolas, there's a little bit of counting you can do. It's really, most time we end up messing it up anyway. So just go with the other now. But they gave it this other point here, didn't they? They gave it this other point. Wonder why? Because we need it. So we're going to put this in for X and Y. So for X, we're going to put in 0. And for Y, it's going to be 0. Well, that's convenient. It doesn't always work out that way. Now, I had one that I did that ended up, that's where the negative showed up. And if you didn't have that right, the whole thing went poof in your face. All right, so we got every box filled but one, so we're just going to put an A right there. And now let's use our algebra skills to solve this thing. So let's do blue. 0 equals, what's 0 minus -2? That's going to be +2. So that's going to be A times 2 squared. Okay, plus 8. And so now let's keep on going. Bring down the 0. Zero's a number. Don't ignore 0. It's a number 2. And then 2 squared is 4. So that's 4A plus 8. Okay, we got to get rid of the 4 and the 8 to get A by itself. So we're going to do the 8 first by subtracting 8. That's how we get rid of it. Is that okay to do? Not if you don't do it to both sides. We got to do it. So I'm real picky about that. I want to see it written on both sides. None of this crossing over and changing sign stuff. This is mathematically correct. All right. And in the long run, you'll be better off. 4A. All right, now how to get rid of the 4? The opposite of multiplication is division. So we're going to divide by 4 on both sides of the equal sign. We'll do the whole thing too. And so that's 8 over 4 gives me 2, and that's going to be negative 2. And that's good. So negative 2, that opens down, working out okay. So now we're going to start this whole thing here over. And what we're going to do is we're going to take and put negative 2 right there. And then we're going to take this negative 2 and plug it in for h, just like we did here, right here. So that's going to end up being what? Plus 2 in the process. And then we're going to take this 8, which is k, just like we did here, and we're going to plug it there. Now, what about the 0, 0? Well, for the final product, we don't need anything plugged in for that. We need a generic xy because it's going to represent all the x's and y's. So what we're actually going to do here is we're going to take this point, we're going to use it and abuse it, and then toss it to the side, okay? Because we don't need it anymore. Now, with people, that's completely inappropriate and rude. Don't do that. But with numbers, it's okay. So we've used this point to be able to figure out what was missing, and now we can write the full formula, the full equation, the full function model rule, the function that they gave us. That was our task, okay? So let's come back up here. So that's going to be f of x equals, man, slipping on me, negative 2x, no, it's minus negative 2 squared plus 8. Well, what's that really going to be? F of x, negative 2. And when it says do not simplify, I don't think it means this part. It means don't try to distribute the 2 out and all that good stuff. Plus 2 squared plus 8. Let me jot that down real quick. 2x plus 2 squared plus 8. Okay, so one more time, this is what we did. Is we put all these blanks in from the formula, plugged in what we could, got the missing, and so we solved that to get an A. All of that just for one thing, to get the value of A. Started all over again, leaving the X and Y in place, plugged in the other things, and there we go. This is our grand function that they asked us to write. So let me type it in. Okay. So negative 2, open parentheses, x plus 2, rooftop squared, right arrow to get out of the exponent, and then plus 8, and fantastic. Got it right. Cool beans. All right, so let's head on down. We got 3 more to go. Okay, write an equation for parabola with the vertex form with this point. This is exactly what we just got finished doing, correct? Okay, so this should go a little faster for us. Number 11. So we said we're using the y equals ax minus h squared plus k. And I'm going to put all these blanks in here because that's all those variables are. And that I'm using y instead of f of x for our purposes here. Is they're placeholders for something else. Okay, and we know that this is going to be h, k, and this is going to be x, y. And we're going to use these two numbers, this point, temporarily, and then so we can find our missing a. So let's plug in our correct numbers here. So 1 goes here, 4 goes there, and we're going to plug in 3 and negative 8 there. And the thing that's missing is the a value. So we're going to go through all this trouble to find A, and it'll be worth it. So here we go, -8. 3 minus 1 is 2. What's 2 squared? 4. So that's 4A plus 4. We got to get A by itself, so both 4's got to go. So we're going to subtract this 4, get it gone. What you do to one side, you do to the other. Okay, so that gives me -4 and -8, make me -12. And then that leaves me with 4A. And then now, when the opposite of multiplication is division, which we do to one side, we do to the other. 12 divided by 4 would be 3. In this case, -3. And there's my A. So we're going to plug the -3 here for the A. Leave the 1 and 4 in for H and K. Okay. So this time I'm going to be streamline it a little bit more so, okay? So we're going to say F of X equals -3, open X minus 1 squared, and then plus 4. All right. So let me jot that down real quick. -3, X minus 1 squared plus 4. We're getting there. We are getting there. -3. And I'm sure you don't need every one of these. That's why you have a fast forward button and a rewind button. Okay. And you can even watch it on faster speed. So as I go through explanations, I can go through them faster in the parts you need. You can rewind and slow it down. Okay. So the I'm sitting here talking, forgot what? X. Okay. Let's see how we did. Well, I looked at the wrong equation on my piece of paper. And you knew that. You knew that was supposed to be a 4. So I was talking too much and not paying attention to what I was doing. And let's try again. There we go. Here we are. So 8 was something else. All right. So 12 out of 13. We're getting there. This one looks like it's going to be a little straightforward here. So what are we going to do? It's got a 3 on the inside and a -4 on the outside. So that's 3 to the left and 4 down. 3 to the left and 4 down. So shifting 3 units left, because it has to be left and right, and 4 units down. Excellent. All right. So this one's up, so that's wrong. This one's right when it should be left, so that's wrong. This one is left, that's good, and down. So it looks like we found it. Boom. Okay, goes a little quicker when they do that for us. And we have made it to number 13. Here it is. Okay, write the absolute value of the equation shown to the right. Okay, so this is exactly like we did a while ago with those two parabolas. Okay, but this time they didn't give us the ordered pairs. Okay, and it's actually, we're going to be able to do something a little quicker because it's an absolute value. We're not going to have to go through as many steps. Okay, we're not going to have to go through as many steps. But we are going to write this equation out. So let's walk this baby out here. So this is number 13, we said. Yeah, finally made it to 13. Slide over here. See the rest of this guy. Okay. So let's get some points here. This first point is -3, -4. So the vertex there, so the vertex is -3, -4. All right. And now look at this point right here. You go down 1, and 1, 2, 3, 4, 5. So that has a slope of -1/5. You're falling 1 and running 5. Okay? So this is just the slope of the line, but since it's part of an absolute value, the 1/5 is what's going to be our A value. And how do I know it's going to be negative? Because it opens down. So what's our formula here? It's going to be y equals A absolute value x minus h closed plus k. So instead of having parentheses and a square, it's just absolute values. Everything else is the same. So we're going to put a -3 here. We're going to put a -4 there and put a -1/5 here. Okay. So I've shortened the process up a little bit, didn't put all the blanks. You might want to do that, okay? Because you'll get this messed up real easily. So I didn't go through all the extra things, which is probably what they meant for me to do. But since it's an absolute value, I can actually count off what that rate of change will be. So it's -1/5. So we'll put all this together here. Y equals -1/5 absolute value x plus 3 minus 4. Okay? So let me write that down real quick. We'll knock this baby out. -1/5, right arrow, and there's the absolute value bars right there. X plus 3, kick out the absolute value bars, no square needed, minus 4. So let's double check that. So that's our vertex, because that's x minus -3, -1/5, that there. So let's give it a try. Good job. All right. Well, there we go. We've done it. So, topic 1, section 2. Help! Maybe it was a little help, and I hope it was. And so, as always, I hope it was helpful. Talk to you later. Bye.